Hello everyone. Good afternoon. This is Ambika from Provoke Trainings. I'm a senior faculty working in Provoke Trainings. I'll be providing you this AWS Snowflake demo today. I'm a senior data engineer. I have total 8+ years of experience in IT industry. I have 4 years of experience in data engineering, especially in AWS Snowflake. I'm a certified Snowflake developer. I'm a corporate trainer as well. I do provide training in my organizations as well as in the outside institutes. Before getting into this demo content, I would like to give a short introduction in the Snowflake data warehouse. Then we'll proceed with this demo. I'm able to see in the real world, there are files coming in for process. They are CSV file, Excel file, text file, JSON file, and API. Whenever the file comes, so we have to extract the data and store the data into the data warehouse. The data warehouse can be Postgres, BigQuery, Amazon Redshift, or Snowflake. I have been working with this AWS Snowflake for the past 4 years. It has got a unique tremendous feature. In comparing to the traditional data warehouse, in the on-premises data warehouse, there is definitely a high storage and maintenance cost in the on-premises when compared to the cloud-based data warehouse. The Snowflake has got a very good feature called pay in use. So whatever the features of the Snowflake I'm going to use, I'm just going to pay for that, use that feature, that's all. So I'm not going to pay extra for anything. The Snowflake has got another good feature. It not only supports in loading the very small file system, it also supports loading of the millions and billions of data, that is a large data volume. It supports in storing the large volume based of data into the Snowflake data warehouse. The third point, the Snowflake has got a serverless architecture called Snowpipe. So whenever there is a file continuously coming into the AWS S3 bucket, the continuous loading happens into the Snowflake data warehouse using this serverless architecture called Snowpipe. We have implemented many projects using this serverless architecture called Snowpipe. And one more thing, whenever the user session is happening, we will be in a complete transparency that when the user has logged into the session and when the user has logged out of the session. And it has got a many external stage, internal stage, external tables, dynamic views, and how to create a views in Snowflake. What is the difference between the secure views and normal views, materialized views? Many concepts are there in Snowflake data warehouse to learn. Now, let me come back to the content of this demo. What is Snowflake? Why to use Snowflake? What are the benefits of it? Architecture overview, key features, data flow or usage pattern, sample demo or use case, limitations and considerations. These are the topics I'm going to cover for today's demo. First, what is Snowflake? It is a cloud-based data warehouse as a service. Cloud-based data warehouse as a service, that is called, it is called DWAS. It supports AWS, Azure and Google Cloud Platform, or all the cloud platform, all the cloud layers are supported by the Snowflake. Separation of the compute and storage for scalability. For example, whatever the queries I'm going to work in my Snowflake, the query computations will be done separately and the storage of those query and the results will be stored separately. So this is for the scalability of the warehouse. If I'm going to use the extra small warehouse, the computation is very high and the storage will be very low. If the storage warehouse size is not supportable, the Snowflake automatically scales the warehouse into another size called small or large. So the computation analysis of the data, the computation of the data will be done separately and storage of the data will be done separately. It is fully managed with automatic optimization. Automatic optimization means whenever I'm going to query some data, I'm going to get some input from the users I could see many incoming data are coming for the process. If the warehouse size is small, the automatical scaling will be done by the Snowflake data warehouse, and the optimization, query optimization will be done. So sometimes it is automatic and sometimes we have to do the query optimization by ourselves. But overall automatic optimization is a management of the infrastructure of the Snowflake. It is taken care by Snowflake itself. No external interruptions or external process or manual interception is not required for this. Why to use Snowflake? What are the benefits of the Snowflake? Highly scalable and elastic architecture. Highly scalable means what? I am going to work in a worksheet in my user session. I am going to handle some query. That query has got a more incoming data for this process. This elastic architecture, what it is going to do, whenever the incoming query is more, there are more data for computation. The Snowflake, if I'm going to sell the default or initial warehouse size as extra small, after seeing the heavy load of the data, Snowflake automatically auto scale it for the larger warehouse size or the small warehouse size, large warehouse size or extra large warehouse size. So this elasticity is very important in this architecture, and that's why it is highly scalable. It is able to scale up the performance and scale down the performance of the warehouse. Next, it supports structured and semi-structured data. Structured data means JSON, no, not JSON file, Excel file, CSV file, text file, API data. Those are the structured data. Semi-structured is JSON. JSON takes a format of storing as Python dictionary, key colon value. This is the format it is going to store in the JSON, semi-structured data. So whenever you are going to load the JSON data into the Snowflake data warehouse, you have to parse the JSON data and then only you can store the data into the Snowflake data warehouse. Pay per use model, cost efficiency. Not like the on-premises data warehouse, maintenance cost and storage cost all are dependent on each other. This Snowflake cloud data warehouse has got a property called pay in use. Whatever the features of the Snowflake I'm going to use, I'm going to pay only for that. For example, I'm going to use the Snowpipe architecture. I'm going to use the external tables. I'm going to use the materialized views. I'm going to do some incremental operation in the Snowflake. For that, the cost efficiency comes. So I don't want to spend for everything. I want to spend only for this infrastructure what I'm going to implement in this project. That is the concept called pay per use model. Concurrency handling. Concurrency handling means multiple workloads run independently. And I have a set of users and I have a set of process. The process coming one by one. So the Snowflake is able to handle this process one by one by using the batch loading or continuous loading. Similarly, the set of users continuously sending me the data. One after the other user continuously pushing the data into the Snowflake data warehouse. So the computation should be done in the query level, the warehouse level. So the Snowflake warehouse has got a capability of handling this heavy workloads, multiple workloads, and handle the data one by one, process the data one by one. That is called concurrency handling. No infrastructure management is required. Snowflake itself does the infrastructure management that is supported by the cloud service layer of the Snowflake. It takes care of the provisioning of the users. It takes care of the provisioning of the warehouse. It takes care of the security. It takes care of the metadata. Everything is done by Snowflake itself. That is why no manual interception is required. It does by automatically. So no infrastructure management is required. Snowflake architecture and overview. There are three main layers of Snowflake are there. One is storage layer, compute layer, and cloud service layer. In the storage layer, it stores the compressed data and the optimized data. Compressed data means what and optimized data means what? For example, I am receiving some file from the S3 bucket. The file size is not compatible that can be stored in the Snowflake data warehouse. So I have to compress the file size so that it is best fits into the data warehouse. For example, whatever the files I'm getting from the S3 bucket or some external source, the data type is not matching. It has got some duplication of the data. Data redundancy is there. So I want to optimize everything before loading the data into the Snowflake data warehouse so that the data is clean. Next is compute layer, virtual warehouse for the queries and workflows. So the compute layer is taken care by the virtual warehouses. So whenever I'm loading the bulk queries into my Snowflake data warehouse, the warehouse should be able to compute whatever the queries I'm giving for the processing. Next comes to the cloud service layer. It manages the metadata, security and optimization. What is metadata? For example, I'm going to store the data into the Snowflake data warehouse from the AWS S3 bucket from file. The file has got its file name when it is lastly created. So those are the metadata of this particular input data, so that also will be stored in the Snowflake table. What is security? Security means taking care of like whether the authorized users are logging into the Snowflake. Each of the users will be provided with a set of roles and privileges. So with these roles and privileges only, they should be able to access the data or access the objects in the Snowflake. And what is optimization? Again, I told you in the previous step, the optimization is the data inconsistency, data redundancy, duplication of the data, all will be taken care. Everything is optimized and the cleaned data is coming to getting stored in the Snowflake. These all things will be taken care of by the cloud service layer of the Snowflake. Key features of the Snowflake. It supports for structured and semi-structured data. Structured means Excel, CSV file and some other input file. Semi-structured means JSON. JSON takes the storage format of Python dictionary, which is key:value. So before the JSON data getting stored into the Snowflake data warehouse, it should have parsing of the JSON data should happen, and then the data can be stored in the Snowflake. That can be the nested JSON structure as well. So we should know how to handle the nested JSON structure. Next, coming to the time travel, access the historical data. For example, I'm a developer, I'm doing some testing in my project. Accidentally, my colleague has deleted some data which is required for my testing. So what I have to do? So I should check how can I retrieve that data so that I can do my testing successfully. Snowflake has provided a feature called time travel so that it allows me to access the historical data for the past 7 days. Unfortunately, I got this deleted data in 1 or 2 days only. So I was able to complete my testing successfully. It all happened because of the beautiful feature of the Snowflake called time travel. Then comes the zero copy cloning for instant environment duplication. So cloning of the table, cloning of the database, cloning of the schema, everything can be done. So there is no extra cost for doing this cloning. No physical extra storage is required. You are going to refer the underlying table. That's all. What is secure data sharing across the accounts? For example, in my organization, I am going to do the churn analysis. Whenever the new employee has joined the organization, he doesn't have the Snowflake basic account, but he wants to do some data analysis. So now what I am going to do, I am a developer, I am going to create a provider account and the receiver account. So in that provider account, I am going to provide the data sharing so that the new joiner who doesn't have the Snowflake account, they will be able to access the data to do some analysis. They will be provided with some set of privileges to access the data. Once their data is done, their job is done, their privileges will be revoked back. This is the way how the data sharing can be done in the Snowflake account. Automatic scaling and optimization. So for the huge amount of the processing of the data, if the warehouse size is small, the scale up auto scaling of the warehouse will be done by taking care by Snowflake. It scales up the warehouse. If there is no more data, it scales down the warehouse. These are the key features of the Snowflake. How about the data flow in the Snowflake? The ingest data batch or something, batch or streaming. For example, I'm going to get set of data from different sources. I want to ingest this data into the Snowflake either by batch or stream. I want to store this raw data in the landing stage of the Snowflake schema or the process data whichever I'm going to receive from the external source. Third step, I want to do the transformation of the data. So you are going to ingest the data into the Snowflake data warehouse into the landing stage. That can be done by that has to be considered as an ingestion process. Now you are going to store the raw data, the pre-processed data for the analysis. I want to do some transformation in this data. What is transformation? For example, the raw data is having some column names. The same column name the client doesn't want. He wants to do some naming conventions on those columns. So these are the simple transformations. If we want to calculate some business logic, some aggregations or aggregation of data, that is a complex transformations can be done with the raw data, and those data are transformed and will be stored in the Snowflake data warehouse. And later I can query the data using the structured query language, and I can check whatever the transformed data is correct. It is up to the expectation of the customer. Once everything is done, I am going to visualize this data using this BI tools called Power BI or Tableau. This is called the reporting layer. So you are going to ingest some data into the Snowflake data warehouse, store the raw data or process data, do some transformation on the data, and query the data using the SQL. Then finally you are going to see the process data in the reporting layer. And everything is done. Customer is really happy with the process data. Then you are going to share or export the data set in the real time. This is called the data flow. This is the way the data flow is going to happen in the Snowflake. Sample demo session. In this, I am going to ingest and query weather data from an API. I am going to have the Nova Weather API. For that, I need the API first. I want to load the API data into the Snowflake using Python scripting or ETL tool. How can I load this API data into Snowflake using the Python scripting? I can use the pandas data frame of the Python, which supports the analysis process, which is going to store this API data into the pandas data frame. From their pandas data frame, it will go to the CSV file. From the CSV file, it will go to the Snowflake data warehouse once it is transformed and processed. The second is ETL tool. Using the Phytron or Matillion tool, I am going to extract the raw data, bring the data into the landing stage of the Snowflake, do the transformation using the DBT. Then after the transformation is done, you have to load the transformed data into the Snowflake table, Snowflake data warehouse. Second step is transform and clean data. What is the transformation I am going to do? If it is a very small amount of data, so just a small naming conventions will be done. The column name will be changed. That will be done in the staging layer. We have one more layer called intermediate layer, then the mark layer. In the intermediate layer, any small aggregations has to be done that can be done. In the marked, major business transformations will be done. So these are the transformations, naming change, column name changes, any business sales calculation aggregation. These are the transformations we do. There can be a simple transformations or major complex transformations. Everything will be done in the transform layer. That is taken care by the ETL tool, because ETL tool is mainly purposely designed for only the transforming the data. So this transforming the data is done. Then the data is clean. Clean data means no data type mismatch, no redundancy, no duplication of the data, no data inconsistency, all are in perfect formats. Then I am going to load the data into the Snowflake data warehouse. Query and export the results to the CSV. Yes, my now data is good. I am going to query the data to see whether the customer is happy with the data. Now export the results to the CSV or the dashboard. Push the data into the reporting layer so that let them see the data live. So, and demonstrate the ease of the integration and scalability. So when you are going to do this, all these operations, how much you are going to take this integration of the API data into the transformed data. And if the warehouse size is small, how the Snowflake is automatically going to upgrade it, auto scale it. So this is what the demo scenario I'm providing in this demo. This is a very interesting one, and when you are going to work it lively, it will be very good. You will get a very good exposure in handling this real-time data. Limitations and considerations. So Snowflake has got its limitations and consideration. Compute and storage cost can grow with the heavy workloads. If the workload is really very heavy, the computation cost will go high, the computation time will go high, the storage cost also will go high. Cold start time for the suspended warehouse. Initially, all the warehouses will be suspended. So when you are going to resume the warehouse, there is some cold start time. It will take some 2 to 3 minutes to start the service. That time you have to continuously refresh the warehouse too, so that it has to come out of this cold start time. Not ideal for real-time transaction processing. Why? I have experienced this in my project. I have written a Snowflake query which was taking more number of time, 40 minutes, not 40 minutes. It was taking more than 40 seconds to populate the data in the real-time dashboard. Because of this query performance, we are not able to see the data in the dashboard soon. The customer wants to see the data in 5 seconds, but it is coming after 5 minutes. So to reduce this, it is not ideal for real-time transaction processing. So the query performance can be the biggest issue for this reason. To overcome this, we are going for the ETL tool, kind of a DBT, so that it reduces the query performance timing, so that there is no lag in the real-time transaction processing. Data egress charges may apply. So whenever you are going to load the Snowflake warehouse with the more amount of the data, so the data charges also will be high, the computation charges will also go high, and as well as the storage cost also will go high. So these are the limitations and considerations of this Snowflake data warehouse. Comparison with other data warehouse. Redshift. Amazon Redshift is a tightly coupled compute. It means like it is closely connected with the storage and computation. So less flexible in scaling. So whenever there is a huge amount of data coming for the processing, the auto scaling of the warehouse, scaling up and scaling down cannot be done parallelly. So that is a limitation of the Redshift. In the BigQuery, serverless but less control over the compute sizing. So this is serverless architecture. So serverless architecture, but again it has got a less control over the compute sizing. So whenever there is a huge amount of data coming for the processing, when there is a warehouse is not able to support these operations, so the BigQuery, what it will do, again it is not having the good control over the compute sizing. So that time there will be a lag in the computation of this data. Coming to the Snowflake, it has a balance between the flexibility, performance, and ease of use. So the Snowflake, whenever the data is loaded, when it sees, we can oversee that data is coming more, it can auto scale the warehouse. It scale up the warehouse and scale down the warehouse. And the overall performance of the Snowflake will be taken care. So there are 3 layers of the Snowflake for that. We have the storage layer. We would have seen this in one of this slide, in the previous slide. I'll just have a small review on this. So this is the storage layer, computer layer, and cloud service layer. Mostly the cloud service layer will take care of all the metadata, security, and the optimization. So that's this cloud service layer takes care of the infrastructure management of the Snowflake. The compute layer will take care of the virtual warehouse operations, and storage layer will take care of the data storage. So that is what, when comparing with the other data warehouse, the Snowflake has got a balance, performance, and flexibility. Performance means it takes care of the computation, it takes care of the storage, and it takes care of the infrastructure management. That was really not, these features are not available with the BigQuery and Redshift or any other data warehouse. Getting started with the Snowflake. Now I'm good. I know all the concepts of the Snowflake. I want to practice it lively. So for that, I have to create a free trial account on the snowflake.com, load some sample data set or your own data set, use Snowflake Web UI or Snowflake SQL client. So Snowflake has got some different methods how you can enter into the Snowflake and you can work with some data. One is Web UI, which has got a Snow site worksheets. Another one is Snow SQL, which is a command line interface, which is called Snow SQL. That has to be downloaded and installed separately in your system. That commands or almost you'll be using the same Snowflake query there, but some authentication login system is there in the Snow SQL that we have to follow according to the syntax. So in the Web UI, you'll be able to enter the queries and run the queries and see how the data is. So using this Web UI and Snowflake SQL client, you are able to interact with the Snow site worksheets or the worksheets of the database. That's the way you'll be started working with the Snowflake database. And once you are loaded the data, you run some queries and tested the data, then you can connect to the reporting tools like Power BI or Tableau or using the Python connector, you can just visualize the data in the reporting layer. Summary. Snowflake simplifies the data warehousing in the cloud. So Snowflake is going to it itself is going to take care of the data warehouse management, security management, metadata management, cloud service. These all are taken care by the cloud service layer of the Snowflake. That is why it simplifies the data warehousing in the cloud. It enables the fast scalable analytics without infrastructure overhead. Means it enables the fast access of the data. It does the analytics by itself. It enables the scalable analytics by increasing the scaling up the performance of the warehouse and scaling down the performance of the warehouse without infrastructure overhead. So you don't need to bother about any infrastructure maintenance. Snowflake itself will take care of the infrastructure maintenance. So the manual interference is not required here. Ideal for data engineering, analytics and sharing workloads. So this is highly suitable for the data engineering. Roles like a data engineering, analytics role and sharing the workloads. So this is about the Snowflake data warehouse, that is a cloud data warehouse. So coming to the point, what are the prerequisites for learning this course? To started working with the Snowflake data warehouse, we should be good with the structured query language. So in this content, I'm going to provide you the structured query language, introduction to database, RDBMS or NoSQL. Relational database management system. What is relational database management system? What are the types of database? Relational database plus non-relational database. What is SQL syntax? What is data definition language? That comes under create a data table, drop table, alter table. What is DML? Data manipulation language. How to insert the data into the table. How to update the records in the table. How to delete the data from the table. What is DQL? Data control language. DCL actually it is. It is data query language. DQL is data query language. Select some of the records from the table using the where condition and use order by to whether order the data in ascending order or descending order and limit for certain number of rows for the retrieval. How to filter the data using the like operator in, between and or not. What are the SQL joins? Now, I'm not only going to join with only one table. I'm going to join with the multiple tables in my database. For that, I should use the joins in the database that will join on particular column. It not simply, if you are not going to join on the particular column, then it is called cross join. The cross join will take all the data from, for example, I have an employee table and department table. In the employee table, I have 1000 rows and department table, I have 1000 rows. If I am not going to join these two tables on particular column, it is going to cross join. It is going to pull all the 1000 rows from department table and all the 1000 rows from the employee table. To avoid that, I should join the tables with some particular department ID or employee ID columns so that the matching employee IDs and department IDs rows will be populated. So that is where we have the different types of join in SQL called inner join, left join, right join, full join and self join. So the left join will pull the empty records from the right side table. The right join will pull the empty records from the left side table. And full join will pull all the empty and non-empty records from both the tables. But full outer join is basically very costly operation. Basically, all the organization will go for the natural join or inner join. And how to do with the aggregations, how to count the number of rows, how to calculate the sum, average, max, min, group by, having, all these operations in the set of records in the database table. What are subqueries and nested queries? Query inside a query. What is common table expression? Instead of writing the multiple SQL statements, I am going to create a common table expression which will have the set of selection of the columns. So that common table expression will be used inside another SQL so that it reduces the time of the development as well as it reduces the time of the loading of the data. Windows functions, row number, rank, lead and lag. Row number will give you the set of rows in the even ranking number 1, 2, 3, 4, 5. In this rank and dense rank, the rank is going to give me, for example, I have a rows, employee ID 1, 2, 3, 4, 5. The employee ID 2 has got employee 2 also has got a salary 50,000. Employee 3 also has got a salary 50,000. So these salaries will come under the rank of 2. And again, the employee 2 salary 50,000 will come under the rank of 2. Employee 3 salary 50,000 will also come under the rank of 2. To overcome that, I am going for the dense rank so that it will not skip the sequence. So the employee 1 has got a 60,000, that is the rank is 1. Employee 2 has got a salary 50,000, the rank is 2. The employee 3 has got a salary 50,000, the rank is 2. And the employee 3 has got a salary 40,000, which is getting the rank of 3. So to not to skip the sequence of this ranking, we are going for the rank and dense rank. Lead and lag will get you the previous row and the next rows of the database table. Case statements and conditional logic, it works same as a Python if conditional statement. If, elif and else. The same way how the case statement is going to work. Using this case statement, you are going to check some condition. Out of this conditional output, you are going to create some column or you are going to use the existing column. So CRUD operation, create, retrieve, update and delete. This is the CRUD operation basically we use in the SQL, then joins, then window function, then subqueries. So before started working with the Snowflake fundamentals or Snowflake data warehouse, I want you all to be thorough with this prerequisite structured query language. So first we will complete the structured query language course, then only we will be entering into the Snowflake data warehouse. I hope you all are clear with this. And finally, who are eligible to learn this course? The college students, working professionals and housewives who want to export themselves in the cloud-based data warehouse, who want to upgrade themselves from the on-premises data warehouse to cloud-based data warehouse, and they want to certify themselves in the cloud-based data warehouse like a Snowflake, who wants to learn the advanced architecture of the cloud-based data warehouse. Everyone can learn this course, can take this course. Once you complete this course, I am very much assured that in the beginner level you can get the salary between 5 to 6 lakhs per annum, and in the intermediate level you will be paid 12 to 14 lakhs per annum in the Snowflake data warehouse architecture. In the expertise level, definitely you will be paid between 20 to 25 lakhs per annum. The Snowflake data warehouse is a very high competitor for the other data warehouse in the existing world. It has got the unique features of the cloud supported data warehouse which the other data warehouses are not having. If you are going to learn this course, I am very much assuring that you will be highly benefitable. And I am a real-time working employee using this Snowflake data warehouse. I know the pits and falls of this Snowflake data warehouse. And I really love working with this architecture and this technology, and which has been widely used in the ETL tool as well for transforming the data and managing the data. And mostly it is supported by India, in India, all the organizations are supporting this Snowflake data warehouse, but it is widely used by the US organizations and the foreign organization who handles millions and billions of data for their customer. I really recommend you, whomever going to take this course are really going to be beneficiable, because that architecture is that much interesting and it is very challenging. So this is what what are the trends of this Snowflake data warehouse, and who are eligible to learn this course, and what is the salary they can expect after completing this course. And prerequisites is you have to complete this structured query language before getting into the Snowflake architecture. I am really very happy for giving this demo. I hope everybody will be very much benefitable by this demo, and definitely we'll see you in the course soon. Thank you all.